Students, you can see my screen now. Students.
Yes, sir. Can see.
Okay. So I'm starting. Okay. Please mute your mics now. You can unmute your mics when I will finish this lecture. Okay. Please mute your mics. There is some disturbance from your side. Okay, so now we have in last lecture, student, we have already discussed about, and we have started the first unit in which we already discussed about the power generation technologies, and we have completed the working as well as what are the various factors that plays an important role when we have to install a thermal power plant, what will be the advantages, disadvantages. We have also covered the complete working of the thermal power plants in the last lecture. After that, we have also discussed about the hydropower plants also. And in that also, in hydropower plant also, we have discussed that what are the various hydropower plants in South Africa, what is the capacity we have, what are the different types of the power plants available in the South Africa, what is the total capacity of the hydropower plant. We have discussed this part in last class. After that, we have also discussed that what is the or what are the various advantages of hydropower plant. Then we have also discussed that why it's difficult to install these power plants. Okay, and then we have also discussed regarding the total capacity also for the thermal power plant as well as hydropower plant also. Okay, and then we have discussed what are the favorable sites that play an important role when we have to install the hydropower plant, considering the availability of water, storage of water, type of the land, and lastly the transportation facilities. Then we have discussed the working of hydropower plant, considering that we need a dam, we need a valve house, we also need a penstock, and then we also need the turbine house. Okay, the turbine should be coupled to the alternator. Then we have also discussed the importance of the surge tank, that what will happen if the load will suddenly thrown off, or there's a sudden increase in the load on the turbine generator set, then how the surge tank will help to in avoid bursting the penstock. We have discussed this thing in last class. Then we have also discussed about what are the various types of the water turbine like Francis turbine, the Kaplan turbine. We also discussed about the reaction turbine. Then we also discussed that what are the roles of what are the major, or I can say what are the auxiliary equipments in the hydropower plant. Like we have discussed about the exciter, we have discussed about the transformer, the three-phase transformer. Then we have also discussed about the circuit breakers and isolator, and then how the power is fed to the grid. We have discussed this thing in last class. Okay, so now students, we are today for today lecture we are starting with the nuclear power plant. Okay, now you see that the students, that for nuclear power plant, guys, the main concern is that we have very limited capacity or limited power plants, nuclear power plants in the South Africa. The total capacity of power generation is only 1860 megawatt. Coburg Nuclear Power Station in Western Cape, the total capacity is, guys, 1860 megawatt. It means we have the two large turbine generator, and each is having the capacity of 970 megawatt. So the total capacity is 1860 megawatt. So now you can see very easily that in comparison to the thermal power plants and the hydropower plant, okay, the total installed capacity of nuclear power plant is very less. Okay, and that is what the scope for the improvement, where the future lies for the South Africa, where it is expecting that with the help of these power plant, if some of the, you can say, standardization can be done, some improvement in the design can be done, then how we can meet the future power generation maybe for the next thousands of the years with the help of nuclear power plant in comparison to thermal as well as hydropower plant. Okay, so that's one concern. So now we are starting with the nuclear power plant. Now you see that the nuclear power plant, first thing is that, as we have seen in thermal power plant, guys, and hydropower plant. In thermal power plant, our fuel is coal. Okay, and in hydropower plant, the fuel use is the water for generation of the electrical energy. Okay, so but if we talk about the nuclear power plant, now you see that in the nuclear power plant, we will be using the uranium 235 or the thorium. Okay, so the main concern is that the And I want to make it very clear to you that the working of your nuclear power plant is very similar to your thermal power plant. Only the difference is the regarding the fuel used. Okay, but then also we will see that how the nuclear power plants are much better in terms of, you can say, the running as well as the installation in comparison to thermal power plants. Okay, so first thing is that the amount of fuel required is very small. Okay, because you see that in thermal power plant every day you have to burn the thousands of the tons of the coal, okay, to generate the high temperature steam. But the same can be done, okay, by burning, or I can say, I will not use the word burning, the more technical language is that we will use the uranium 235 to produce the high temperature steam in the nuclear power plant. And that is why there is a considerable saving in the cost of the fuel transportation also, because in thermal power plant every day, okay, on the regular basis you need the coal, so that's why the cost of transportation is very high in thermal power plant. That can be saved in the nuclear power plant. Another thing is that the nuclear power plant, the design is, guys, very compact. Okay, and you can see that the nuclear power plant of the same capacity, okay, the same capacity, they require a very less space in comparison to, if we do the comparison for thermal power plants or hydropower plant than the nuclear power plant. So you can save the lot of space by installing the nuclear power plant. Third thing is that it has low running charge. It means that your running cost will depend upon the fuel, okay, and the uranium 235, because because the nuclear power plant, they depend upon the chain reaction that is done with the help of the fission of slow moving neutrons onto the uranium 235. Okay, that will give you a chain reaction. Once the chain reaction is initiated, then you don't need to spend too much of the fuel. So that is why you can see that we can say that the running charges is very less, because the small amount of the fuel is used for producing bulk electrical energy. And that is why we can say that these types of the plant are very economical for producing bulk electrical power. Another concern is that these plant can be located near to the load center, because you does not need a very large quantity of the water. And another concern is also that you also don't need that these plants should be located near to the coal mine. And that is why we can say that the cost of primary distribution is reduced. Further, you see that all over the world there are the large deposit of nuclear fuels available all over the world. If you go to the different parts of the world, then there are so much of the nuclear fuels available. And that is why we can ensure that if we will use, or we can standardize the design, we can work on the technology use, okay, the turbine use, okay, or if we can save some of the energy in the nuclear reactor, then we can say that we can ensure the continuous electrical energy for next thousands of the year. And that is why we can say it ensures the reliability of operation. So these are some of the important advantages, guys, that why we need a nuclear power plant. Okay, now what may be the demerits of the nuclear power plant? One thing is that you see that in the nuclear power plant, we will be using the uranium or the thorium. Okay, so the fuel used is very expensive and it's difficult to recover. That's one of the drawbacks of the nuclear power plant. Another thing is that because you see that the nuclear power plant, they need a very high, you can say a very higher technical know-how staff, and very highly you can say the very highly or well equipped, I can say, or means that we need a kind of the designer as well as the engineer who has a very deep knowledge. And that is why the capital cost of a nuclear power plant is very high in comparison to other type of the plant, because you have to design such kind of the plant where the radioactive radiation should not escape from the plant in case of any accident in the nuclear power plant. That's one thing. Another thing is that the erection and commissioning of the plant require greater technical know-how. Further, you see that we are using the uranium or the thorium, the fission byproduct. The fission, just a second, guys. The fission. You can see my screen.
Yes, we can see.
I think I have lose the link. You can see my screen, students.
Yeah, we can see your screen.
Okay. Thanks. Okay. Thanks.
See your desktop.
What? Come again. Guys.
Yeah, we can see your slides.
Okay. Thanks. At any time, if you feel that because I also don't know about the reliability of the network of the DUT, then please send a message to me. Okay, maybe on email if because I can't check from here whether I'm away from the system or there is some networking issue. Okay. So that is the one thing, guys. Another thing is that the maintenance charges are very high due to the lack of standardization. Moreover, it's very important that you need to pay the higher salaries to the specially trained persons to employ these kind of the plant, and which further raise the cost of the system. Now, one of the important concerns with the nuclear power plant is that the nuclear power plants are not designed for variable load of the system. Okay, that's very important, and that is why whenever there is a high demand of the power during the peak hours, maybe between the 6 to 8, between the 6 to 9. Okay, so in those cases what we do is that we put the load on the thermal power plants or the hydropower plant. So that is one of the major drawbacks, students, that the nuclear power plants are not designed for the varying load, because there is a nuclear reactor, and the fusion reaction, you can't change the, you can say, you can't change the process of that reaction according to your load requirement, and that is why it is the drawback that it can run on the base load. So if you go in any power part of the world, they use the nuclear power plant only for the base load. The nuclear power plants are not designed for the peak load. In last lecture we have discussed that the thermal and hydropower plant, and out of those also with the hydropower plant, they are well designed for the varying load in the system. Another concern is that one of the major drawback is that the disposal of the byproduct. You see that we are using the uranium or maybe the thorium, so which is the byproduct is radioactive. Okay, it's a highly radioactive, and it's a big problem that how to dispose this radioactive product, and that is why either it has to be disposed of in a deep trench or it should be in sea away from the seashore. Okay, so these are the one of the some of the demerits of the your nuclear power plant. Now we will see that what are the selection of site. It means that what are the factors that need to be keep in the mind when we have to install the nuclear power plant. Okay, guys, you can see my screen, students.
Yeah, we can see your screen.
Okay, just a second. I need to check again if just a second. I need to check. I don't know why there is a networking problem today. Just a second. I want to check if my recording is on so that later also you can see this lecture. Okay, yeah, the recording is on, so that is not a problem. Okay, so some of the important factors which play a major role in selection of the site for nuclear power plant are, first is availability. What, someone wants to say something? Students, you want to say something? Students, any problem?
No, sir, you can carry on.
Okay. Please let me know, because you see that sometimes I just speak on, but I never know whether I'm disconnected from the systems. Okay, so please let me know. Okay, so that's one concern. So the selection of the sites play an important role in nuclear power station. First thing is availability of the water. Okay, now you see that as we have discussed, the working of thermal power plant is very similar to the nuclear power plant, and the exhaust steam which is available at the output of the turbine need to be condensate, and that is why your nuclear power plant should be located, okay, or should be installed at a site where the sufficient water is available. That's why we try our best. The engineers try our best, that try their best so that these nuclear power plant should be located near to the river or canal. If there is not sufficient water available, then in similar to thermal power plant, there should be the cooling tower where the sufficient water can be taken from that cooling tower. So that's first point, the availability of water. Second thing is disposal of waste. Now you see that, guys, this is a very important point, the disposal of the waste. Okay, and that is the thing that need to be considered for it's very important when you have to install any nuclear power plant, because the waste produced by fission in a nuclear power station is generally radioactive. Okay, it's generally radioactive, and it must be disposed of properly to avoid any health hazards. That is why the waste should either be buried in a deep trench. I repeat that either the waste should be buried in a deep trench or it should be disposed of in a sea quite away from the seashore. It should be disposed of in a sea quite away from the seashore. Okay, so that's why this factor play an important role in choosing a site for a nuclear power plant. Third point is that, guys, distance from the populated area. Now you see that the site selected for a nuclear power station should be quite away from the populated area, because what happens in case there is some radioactive emission from the plant, then it will be, and that radioactive radiation emit, or you can say escape from the plant, and then it will be very difficult for the humans, animal, as well as the environment. That's why the engineers try their best to find an isolated place for the nuclear power plant. That's one concern. Another thing, but then also it's very difficult to escape the emission from the nuclear power plant, because a dome is created. It doesn't allow the radiation to escape from the nuclear power plant. Final point is the transportation facility. Now you see that for nuclear power station, there should be an educate transportation facility, because they are the generators, turbine, the nuclear power plant. So if there's any fault or if you need to replace any of the unit, then it should be well connected with the help of the rail, with the help of other transportation to the different parts of the country, as I have discussed with other power plants also, so that your power should not be your nuclear power plant shouldn't be in shutdown position for too long. Okay, so these are the some of the important factors that need to be considered in selection of site for nuclear power station. Okay, now we are moving to another slide. The thing is that this is the block diagram of nuclear power plant, and first I will show you that about the working of this um, nuclear power plant, but after that we will discuss each and every component in detail also. Okay, so guys, you can see that this is the complete representation of your nuclear power plant. Okay, and if you can see that the working, or I will show you right now that the working of the nuclear power plant is very similar to your thermal power plant. The only difference is we have the nuclear reactor in the nuclear power plant. Okay, from the nuclear reactor, the hot metal is flowing. Hot metal is flowing into the tubes of this heat exchanger, into the tubes of this heat exchanger. Okay, and after that, the cold metal is pumped again back to the nuclear reactor. Okay, so I will repeat that there is one major difference, that instead of the boiler, what you have seen in thermal power plant, in nuclear power plant, guys, we have the nuclear reactor from which the hot metal is flowing into these tubes in the heat exchanger. They release the heat to the water. Okay, after that, what will happen? The cold metal is flowing with the help of the filter with pump back to the nuclear reactor. Okay, now the high temperature steam from the heat exchanger is allowed to fall onto the turbine. Okay, so that is why we have the valve here, and by controlling or by regulating this valve, you can regulate your high temperature steam which is falling into this turbine. The output of the turbine with the help of the shaft is coupled to an alternator. As we have discussed earlier also, that your three-phase synchronous generator or alternator is in a doubly excited machine, and that is why we have an exciter here. The power which is generated is stepped up with the help of three-phase transformers. Then we have isolators, circuit breakers, and then finally the power is fed to the grid. After that, you can see that there is at the output of the turbine. Okay, at the output of the turbine, there is an exhaust stream, so it need to be condensate. Okay, and that is why a condenser is available, and you can see that from the river there's a link to the condenser. Okay, so if the sufficient water is available, the steam, okay, which is enough hot, okay, but it's not so much hot, okay, the out, because it is already the exhausted steam, so that need to be condensated with the help of the water that can be fed from the river to the condenser. Okay, in the same way it may be possible if the water is not available, okay, and the water level has goes down. So in that case, the cooling tower, guys, the cooling tower has the water. We store the water in the cooling tower, and then with the help of the circulating water pump, this water is fed to the condenser. Okay, now the exhaust stream is condensate. After that, this water is fed back to the heat exchanger. Okay, so this is the general, I can say, the working of nuclear power plant. But now we will discuss more detail of the nuclear power plant. Okay, let's see now. So now you see that the main parts of nuclear power plant are nuclear reactor, heat exchanger, steam turbine, and alternator. If I want to show you, it's very important: nuclear reactor, heat exchanger, turbine, and alternator set, and the condenser. So we'll not discuss these things in detail because its working is same, but we will focus more on this part, okay, which is totally different, make it different from the thermal power plants. So that's one concern. Now you see that, guys, this is the schematic representation of your nuclear reactor. This is the representation of nuclear reactor. In nuclear reactor, one of the important thing is that this is the reactor. Okay, and inside there is a pressure vessel. This is a pressure vessel. After that, we have the fuel uranium, uranium 235. After that, there is a moderator. The moderator is made of the graphite, and its work is to reduce the speed of your neutrons. Its work is to reduce the speed of the neutrons. And then we have the control rods, okay, that is dig into this container, and these controller rods are made from cadmium. Okay, these control rods are made from cadmium, and after that what happen is that we will discuss now working, that the coolant will flow. Okay, the coolant will flow in these tubes. They release their heat to this vessel. In this vessel, the water is injected from here. The hot coolant is flowing through this tube. It releases the heat to this water, convert into the high temperature steam. The steam is then at the outlets, it's fed to the turbine with the help of your valve, and at the same time it's a continuous process. The water is injected here and the steam has been taken out. Once this coolant will give the heat to this water, okay, then this coolant with the help of circulating pump is fed back to your nuclear reactor inside your pressure vessel. Okay, so that's one concern. Now we will discuss this thing in detail. Okay, Joshi, you have any question? So now you see that, guys, it's very important, that is your chain reaction. Okay, your nuclear fission is done by bombarding uranium nuclei with the slow moving neutrons. That's very important, guys, that your fission is done by bombarding the uranium nuclei with slow moving neutrons. So what happened now, that when you bombard the uranium nuclei with a slow moving neutron, it splits the uranium nuclei, and when you bombard it, it split and it will release some of the energy. It release the heat energy. Okay, and at the same time it also emit emission of the neutron, that is known as fission neutron. These fission neutrons, guys, they split into in a process such as 2 into 4, 4 into 8, 8 into 16, that these fission neutrons cause further fission and then further heat energy is released. Okay, so but the concern is that if this process, and this is known as chain reaction. Okay, your uranium is bombarded with slow moving neutrons, it split into uranium nuclei, heat energy is released, and neutrons, it further causes further fission. So this is a chain reaction. So once the chain reaction is initiated, guys, then it's a continuous process, and then what will happen, your heat energy will release, it will go on, go on, go on. If this process, guys, continues, okay, so this happen here in this is the uranium and this is the moderator, it happens here, okay, in the nuclear reactor. That's why the nuclear reactor plays an important role in the nuclear power plant. Okay, so if this process continue, guys, then in a very short time the large amount of the heat energy will be released, and if this fission reaction is not controlled, then it can just explode your nuclear reactor. So nuclear reactor is already very costly and you can't control this reaction, then you will lose a lot of money in the nuclear power plant. That is why in a reactor controlled chain reaction is allowed. Okay, it means it is done that by systematically removing the fission neutrons from the reactor. Okay, the greater the number of fission neutrons removed, the lesser is the intensity of the energy release. How it is done, guys, you can see that here are the control rods. Okay, these are made of cadmium. Okay, and the cadmium has the property of absorbing the neutron. So that is why what the engineers do is that, okay, but it's an automatic process, I'm just telling you the working, that when we have the large amount of the fission reaction, so we dig these control rods inside into the reactor, so they absorb the neutrons, and when we need the large amount of the heat energy, we have to increase the generation, we dig it out from the nuclear reactor. So in this way we control the chain reaction or the neutrons, because if large number of the neutrons are available, then what will happen, large amount of the heat energy will release. Okay, so that is the beauty of the control rods, guys, that nuclear reactor is an apparatus in which nuclear fuel uranium-235 is subjected to nuclear fission. It controls the chain reaction that starts once the fission is done. If the chain reaction is not controlled, as we have discussed, it will result in an explosion due to the fast increase in the energy released. After that, guys, as we have discussed, I'm repeating to make you understand in a better way, the nuclear reactor is a cylindrical pressure vessel, and there is a fuel rod of uranium, moderator rods, and control rods. Right now we have seen that thing. The fuel rod constitute the fission material, and it releases the large amount of energy when it is bombarded with slow moving neutron. Another thing is that, guys, that moderator consists of graphite rod, which enclose the fuel rod. If you want to see, I can show you again. The moderator consists of the graphite, which enclose your fuel rod. This is the moderator. This is the uranium. This is the uranium. This is the moderator, and these are the control rod. Okay, so that's one thing is that, and the moderators slow down the neutron before they bombarded the fuel rod. Control rods are made of cadmium and are inserted into the reactor. As we have discussed, cadmium is a strong neutron absorber and thus regulate the supply of neutrons for fission, because if the neutrons are available, the fission reaction will continue and it can burn or it can explode your reactor. So that's why it is very important to control that fission reaction. Okay, now when the control rods are pushed in deep enough, as we have discussed, they absorb most of the fission neutron, and hence very few are available for chain reaction and therefore further stop. However, as they are being withdrawn, means that your control rod has been pulled out, okay, has been pulled out from the nuclear reactor. What will happen? Your more and more of fission neutrons will cause the fission reaction, and your intensity of chain reaction means the heat produced will be higher and higher. So it means, guys, that by pulling out the control rods, the power of nuclear reactor is increased, and if you push them, then your power is reduced. I have already discussed with you that in actual practice, this process is automatic, okay, as per the requirement, okay. But then also your nuclear reactor, because it's a very costly and sensitive process, so that's why the nuclear reactors, or I can say the nuclear power plant, are not designed to carry your variable load on this system, okay. And one thing is that when what we are doing is that with the fission reaction the heat is produced. Now this heat produced, guys, this heat produced in the reactor is taken by the coolant. The coolant generally used is sodium metal. Okay, why the sodium metal has been used? Because it get heated, it takes the heat from the reactor of the system. After that, when the coolant will flow into the heat exchanger, it releases the heat to the water. So it means that this coolant has a very good property. It absorbs the heat, then release it to the water, so that that water can be converted into the high temperature steam. Okay, that's one concern. So that's the another concern, heat exchanger. The coolant gives up the heat to the heat exchanger, which is utilizes in raising the steam. After giving up the heat, coolant is again fed to the reactor. Okay, as we have seen that I've already shown you that the coolant, the sodium metal, flow into these tubes. Once it gives the heat to this water, then your circulating pump will again fed the coolant into the reactor. So this is the continue process, guys. This is the continue process. After that, we have a steam turbine. There's not much difference between the thermal power plant as the nuclear power plant. So the turbine, those are used in thermal power plant. The same turbines can be used in your nuclear power plant also for generation of electrical energy. Your turbine is coupled to your alternator. At the same time, at the output of the turbine, there is an exhaust stream. It need to be condensate. After that, that water is fed to the heat exchanger through the feed water pump. Feed water pump is also in a continuous process. Then we have the alternator, which convert the work done of the turbine into the electrical energy. The output from the alternator is delivered to the bus bar, or I can say fed to the grid with the help of transformer, circuit breakers, and isolator. Okay, so with this, I believe that your thermal power plants, hydro, and nuclear power plants are finished. If you have any question, you can ask me now, or if you don't have any question, then we can move to another unit. Please, guys, do you have any question regarding first unit? We completed first unit now. If you have any question, you can ask from me. If you don't have any question, then we can start the new unit, the transmission line. Please, you're free to ask. Please, guys, if you have any question, you can ask from me from first unit. If you don't have, then no problem.
Sir, what I wanted to know, man, is the slides that you are doing, are they on MS Teams?
I have already created a group on the MS Team. Okay, and my strategy is always in such a way that today we have completed this unit. Okay, so today most probably I will post these slides onto the MS Team. Okay, if you go into the file section, I will upload it today so that you can follow it from today onwards. And once we will complete next unit, then after the completion, then I will post the next slide also. I move always in such a way, because if I post it earlier, I've seen that then the student doesn't come to the lecture. and then they get confused because these are the notes that was made by me. I will also give you the notes that I have made from my hands. So there's no use if you without using referring the notes without following the lectures. Yeah. Do you have any concern, guys? Any concern, any question regarding the unit 1? We have completed thermal power plants, hydropower plants, and nuclear power plant. If you have any concern or question, then it's fine. Otherwise, I will start the next unit now.
Before we go this, is there any
Yeah.
calculations that are going to be involved in this? Because I see you just taught us theory.
Yeah. You see that the unit 1 is regarding that you should have a knowledge of the various power plant and the various technique. Depending, you can see that I can teach you because I have teach it to the master guys also, the new other gas power plants, the renewable like PV, wind, others also. But the time doesn't allow me to discuss each and every plant. So that's why. So we don't have any calculation in this unit, but now we will start the transmission line that is totally dependent on the calculation only.
Okay, no, that's fine.
Okay.
Any
thank
other
you.
question, guys? Mr. Naidu, last time also you sent an email to me. Do you have any concern or question?
No, everything's okay now. Clarified.
Okay, thanks. Thank you so much. Then also, if you have any problem, you see that, then you can write an email to me and you can come to my office also. Most of the time I'm available in my office. Okay, so do you want me to, let's start with the next unit now? Guys, if you don't have any question, any concerns, then I should start now next unit, transmission lines. Is it fine?
Yes, sir.
That's it,
Okay.
sir.
It's fine.
No
What?
problem.
It's okay.
Okay. No issue. So just, okay. Just give me only 5 minutes to show you the notes and then we will start now. Okay, just give me 5 minutes only. Okay guys, now let's start the new unit, the transmission line modeling, as well as to see the impact as well as the benefit of the different transmission lines. We'll start now. Okay, and just a second. Okay, now you can see my screen now, guys.
Yes, we can see.
Okay, now, okay, guys,
Yeah,
you
we
see
can
that.
see your face.
Okay, no problem. Guys, you can see that you can use the book Power System Analysis by D.P. Kothari and I.J. Nagrath. That is a very good book. Also, that the Principle of Power System by V.K. Mehta. Okay, you see that I have the soft copy of this book, but as per new duty rules, I can't give you the soft copy. So you have to go to the library to find these books. Okay, and I can't post these books also on the MS Team. That is not allowed to me. Okay, but now this unit is transmission line. It has too much of the calculation. Okay, I will post these notes also on the MS Team once we will complete everything. But you see that what I do is that I just try to solve each and everything with my hands. So there may be that you can find the different steps in my notes as well as the different in the book. So there's nothing to worry. It's totally up to you. You are totally free that what you need to follow. I follow my notes because I know that I have designed in such a way they are very simple to learn and it's easy to grasp the concept also. Okay, so now we are starting with the next unit, and that is, so now you see that I have written the name ABCD parameters, but it's not an ABCD parameter. It is the modeling of transmission line. And now you see that before going into the modeling of transmission line, guys, now you see that our power system, okay, that is divided into three parts: generation, transmission, and distribution. Our concern as an electrical engineer is always that we generate the electrical energy at remote locations where the ample quantity the fuel is available, and then what we do is that we transfer that power to the load center. Load center means your houses, universities, your malls, to the places where the power is required. So that is why, guys, it's very important that we need our transmission system which is very, or I can say, a highly efficient. That is an important, you can say, concern. So that is why, guys, you see that the transmission lines plays a very important role in transferring of the electrical energy from generating stations to the substation or to the distribution centers or to the load center with maximum efficiency. Guys, you see that, for example, the 100 megawatt is generated, okay, in thermal power plant, maybe hydro or maybe nuclear. It's a very simple example. Then we want that minimum losses should be there across the length of the line. It should not be in such a way that the 100 megawatt is generated, then at the load center you are receiving maybe the 97 megawatt, maybe the 95 megawatt. No, we can, as an electrical engineer, the power is already very costly. We can't afford all those things, and that is why as an electrical engineer our concern is that we should have a transmission system which should be highly efficient. Okay, so that is why the role of this unit is that we will see now. Okay, and let's see that how much we can do now. Okay, so now another thing is that we have already discussed now transmission network. Okay, so because why we are studying this unit, the important thing is that we need to know the what will be the voltage that should be available at my receiving end. Okay, what are the losses? How should I calculate the efficiency of my transmission line if I am transferring the electrical power over the length of the line, okay, over the or with the help of the transmission line? And that is why in the picture your ABCD parameters, or I can say, you see that the ABCD parameters come into the system, okay, or comes into the knowledge, or I can say that the transmission line, okay, the transmission line, for the simpler calculation, okay, it is divided or it is named as two-port network, one port here and one port here. Very simple. Okay, this is my transmission line, this is my your input port, and this is my output port. Okay, at input the voltage is defined Vs. Vs means sending end voltage. I have defined the current as Is, that is sending end current. At the receiving point, okay, means at your load center, or I can say your substations, okay, or I can say the distribution substation. We have the voltage which is named as VR, receiving end voltage. We have the current IR, which is known as a receiving end current. Okay, so you see that this network is designed, guys, in such a way that entire transmission line is linked in such a way that we have one input port named as PQ and one output port has R and S. We have sending end voltage, sending end current on this side, and we have the receiving end voltage and the receiving end current on this side. So it means that your transmission line will give a link between the sending end voltage and the sending end current, as well as the receiving end voltage and the receiving end current. And that is why this network is known as two-port network. One input, one output. The input is PQ and output is RS. Okay, it is known as two-port, four-terminal PQ, R and S in a very simple language. Okay, and I have already mentioned here what I discussed with you: sending end voltage VS, sending end current IS, receiving end voltage VR, receiving end current IR. Okay, here I have not shown it, but in this block, in a very simple, in a non-technical language, I will use to define the four parameters A, B, C, and D. Okay, what is the significance? That with the help of calculating A, B, C, and D, I can find the relation between the sending end voltage and sending end current and the receiving end voltage and the receiving end current. So that is the beauty of ABCD parameter, because sometimes the lengths, the transmission lines are the 1,000 kilometers to 1,000 kilometers long. So it's difficult to calculate all the parameters. So that is why we need certain constants to calculate all the, I can say, the voltage, your losses, your efficiency, your voltage regulations. There are so many things. We'll discuss all those things now. Okay, so here I've written that ABCD parameter, or they are also known as transmission line parameter, provide the link between supply and receiving end voltages and current. Assume that circuit is to be linear in nature. Okay, so don't get confused. What do you mean by linear in nature? When in future any of you decide to do your master's or PhD, then we will discuss this thing. Then what do you mean by linear or the non-linear networks? Okay, so basic thing is that now we already got the information about this two-port network. So I have said A, B, C, and D in a very simple language. Now we'll try to maintain, or we'll try to build some equation so that we will have a certain relation between these quantities and these quantities. Okay, my first equation, what we have tried to define is VS, the sending end voltage. Sending end voltage, I can write A, sending end voltage is equals to A into your receiving end voltage VR plus B, the constant, into your receiving end current IR. So your first equation, that's VS equals to AVR plus BIR. That's first equation. Okay, we are always interested, guys, to know that what is the relation between your sending end voltage with receiving end voltage and the current. In the same way, we have one more term here, that is IS, sending end current. So I can write the C into receiving end voltage VR plus D into IR. That's your second equation. VS AVR plus VIR, IS CVR plus GIR. So it means that by calculating these values, it's easy to know the relation between sending end and the receiving end. Okay, and it's very important, guys. You should know these things, because I've seen that the students get confused all over the time that what do you mean by the two-port network. Okay, so that is why if you have any confusion, you can ask me. So now another concern is that, guys, these two equations are very important. You don't have to learn. I have already told you the concept here, that what is the beauty of these two equations, and these two equations play an important role. Okay, so this is one concern. Now another thing is that, guys, that in transmission line, or maybe in complete electrical energy, only there are two possibilities, and these two possibilities are very important. Either what can happen, there may be a short circuit, or it may be an open circuit. Okay, so it means if you see that at output port the circuit becomes open. If your circuit becomes open, then what will happen? Your IR will be 0, your no receiving current. Okay, there will be no flow of receiving current on the output port if your circuit becomes open. Okay, but if in case your circuit becomes shorted, if your circuit become shorted, guys, then what will happen? Your VR receiving end voltage will be 0 because your current will be maximum. Why we say that is a short circuit? Because your short circuit current will exceed the normal rated current of that equipment or maybe for that conductor. Okay, so that's one concern, guys. And now we will proceed in such a way that if your receiving end, we have only two conditions, guys, so there's nothing to confuse. I don't know what is written in the books. Okay, if receiving end is open circuited, if receiving end is open circuited, I've already discussed with you, so in that case there's no flow of IR. There's no flow of IR. So if there's no flow of IR, I have assumed that IR will be equals to 0. Okay, so if there's no flow of IR, your IR will be equals to 0, guys. So in this equation, if my IR is 0, means the receiving end is your open circuited, then this term will be 0, and I can write that the value of my A will depend upon this will go here on downside Vs by VR. So if I have the sending end voltage as well as the receiving end voltage, assuming that my circuit is open circuited, means IR is 0, I can find the value of constant A. You cut this, okay, and it is a unitless quantity. Okay, so that's I can say the unitless this term, okay, not the quantity. Okay, so that's one concern. Another concern is that, guys, if receiving end is short circuited, so there may be possibility, we have seen that these two terminals if become shorted, then what will happen? Then in that case your VR will be 0. Okay, so if VR will be 0, guys, I have written here, if receiving end is short circuited, VR is 0. So again come into this equation, if VR is 0, then your A will be 0. Then you can find the value of B, that will be equals to Vs. This term will go down, it will be Vs by IR. Vs by IR when your receiving end will be short circuited. Okay, so in this here the unit will be V by I, it is ohms. Now same thing can happen to this equation also, Is equals to CVR plus DIR, guys. Okay, so here if receiving end IR equals to 0, if IR is 0, then C equals to, this term will come here, Is by VR. Okay, if your VR is 0, if your VR is 0, then I can write that D equals to Is by IR. Again, it's unitless, and here the unit I by V will be mho. Okay, so if for any numerical you have to find your A, B, C, D parameter of any transmission line, okay, then you can find by considering open, maybe the condition is given to you, whether it's an open circuited, it's a short circuited, you can calculate A, you can calculate B, you can calculate C, you can calculate D. Okay, so with this, your ABCD parameters are done. Now we move to next topic. Next is, guys, transmission line. Now you see that, guys, the transmission lines are classified on the basis of their length. We have three different classification. First is short transmission line, second is medium transmission line, and third is long transmission line. Guys, short transmission line, the length is up to 60 kilometers. Okay, length is up to 60 kilometers, and this classification has been done on the basis of the length as well as the voltage. So I have written here, and you see that this is not very hard, that okay, no, if it falls into this, then only the length is the short and medium. It can change, guys, depending upon the latest research what is going on, and according to that, it's not very, it will change your calculation. Others say no, it's only a classification. Maybe in the books some different length is written. Okay, So according to me, the short transmission line, if the length is up to 60 kilometer, they are treated as short line, but the voltage level should be less than 20 kV, kilovolts. Okay, the medium line, I have classified the length between 60 to 160 kilometers. They are treated as the medium transmission line. Okay, and the voltage will be 20 to 100 kV. And finally, the long transmission line, okay, and they are above 160 kilometers, they are 1000 kilometers long, they are 2000 kilometers long, and the voltage level will be greater than 100 kV. So this is the classification, guys: short, medium, and long. Okay, and as per our discussion now, you see that because I can teach you all three lines, okay, but I believe that the long transmission line, the derivation is very difficult, and I have seen that most of the time the students cry, they won't be able, when I have given these derivation for 20 marks in the exam, so it's difficult for them to get that 20 marks. So that's why now we have decided in such a way that we are discussing short and medium lines, and for long we can discuss some numerical problems. Okay, but if you want, I can teach you long also, that is not a problem. I have discussed each and every transmission line here in all step with my hands. Okay, so that's one concern. So first, now let's see that still we have the time, so no problem. So we will start with now short transmission line. Okay, now you see that, guys, short transmission line. Short transmission, now we are going into the modeling of the transmission lines. Okay, now first we are discussing short. The length is 60 kilometer and the voltage is less than 20 kV. Okay, now short transmission line, it's very important, guys, to understand, because my concern is always to understand the concept that in short transmission line the line capacitance effect is very small. So that is why when we do the modeling of the transmission line, we neglect the line capacitance effect. That's first point, and it's very important. Okay, after that, here to do or to calculate the various other parameters, I have represented here in such a way that my transmission line is represented by that my line will have a certain resistance and it will have certain reactance, XL, the leakage reactance in a more technical language. Okay, so and this transmission line, I have tried to make a very simple circuit to let you understand the concept. It will have two input ports like this, one and two output ports. Okay, so here I have written positive, negative, and the voltage at this point I have assumed Vs, the sending end voltage. Okay, after that, guys, what I have done is that I have assumed that my current Is, sending end current, will flow across the length of this line, and here my load is there. Okay, now you see that I'm not going into that detail whether this load is resistive, inductive, or capacitive. Okay, because it's very important as an engineer to know what kind of the load it is. Okay, because we are doing the modeling, but then also I will tell you in the end that how to represent this thing. Okay, and I have assumed that my current is flowing across the load, this is IR, the receiving end current, and I've assumed that there is a voltage between these 2 points, positive and negative, which is known as receiving end voltage. Okay, so now circuit very simple, guys, that I have a resistance, I have the reactance, okay, I have the sending end voltage, sending end current, receiving end voltage, receiving end current, and here I have the load, and I have marked an arrow in this direction that I will move in clockwise direction in this loop. Okay, so I will move clockwise in this loop. Okay, now for modeling of this transmission line, one thing is that first I have written, now you see that there is no junction on break or break across the length of this line. So I have assumed that my sending end current Is will be equals to my receiving end current. That's my first equation. Okay, Is is flowing across the line, and I have assumed that Is equals to IR. That's my first equation. Okay, I have already told you that the capacitance effect of short line is very less, so we assume it to be 0. After that, guys, it's very simple. Apply the KVL in loop 1. I have written 1 to understand, and I'm moving in clockwise direction. Okay, so guys, you see that I will move from this point like this, and I will come back here. I don't know how much you know about the mathematics, but power system is totally depend upon all these conditions. So I assume that Vs, I start from this point, Vs, if I move from this point to this point, there will be the drop in the voltage. I will write Vs minus Is into R. Okay, here minus Is into XL. Okay, and finally, okay, this is only for your representation, guys, minus VR equals to 0 in a very simple steps. Okay, after that, these terms taken on this side. Okay, so it will be Vs equals to Is into R plus Is into XL plus VR equals to 0. Now it's very important, guys, that whatever you do, but you have to remember one thing, your all equations should end up in these form. Vs equals to AVR plus VIR, Is equals to CVR plus DIR. Okay, so now here what I have done is that Vs equals to, I will repeat, Vs minus Is into R minus Is into XL minus VR equals to 0. Okay, Is is taken common from here, so it becomes R plus XL plus VR. Now R plus XL, guys, that is an impedance, represented by Z, and the reciprocal admittance represented by Y. Okay, in electrical engineering, so I will write it Vs equals to Is into Z plus VR, and I assume it to be equation 2, or I can say equation 2. Okay, so that's one thing. Another thing is that we have discussed that to find ABCD parameter of maybe short, medium, or maybe long, sending end voltage, sending end current, receiving end current, receiving end voltage. Vs equals to A into VR plus B into IR. Is equals to C into VR plus D into IR. Third and fourth equation. Now, I have to find the values of A, B, C, and D. I've already told you, or we have discussed, that whatever you do, you have to end up by making the equation similar to these are the two general equations. Now, you see that my first equation is Is equals to IR, sending end current is equals to your receiving end current. Okay, now from equation 1 is Is equals to IR, sending end current equals to receiving end current. Okay, so I can write this equation on the basis of this condition. Is equals to, because there is no VR term, I can write 0 into VR plus IR. Okay, I repeat again, from condition 1 or equation 1, Is equals to IR. I can write this equation in such a way that Is equals to 0 VR plus IR. Okay, 0 means, because 0 means this term will be 0. So then your equation will be Is equals to IR. This is the another way to write this equation in terms of this equation. Okay, guys. So that's one equation. Now, if I compare this equation with this, so I can write the value of C will be 0. I can write my value of C will be 0. Here, there's nothing, then I can write my D will be equals to 1. So by comparing equation 4 and 5 as per the condition Is equals to IR, I can write my C equals to 0 and D equals to 1. That's the value of C as well as D, guys. Now, you see that we have equation Vs equals to AVR plus BIR. Now, we will compare this equation with this voltage equation. where I can write Vs equals to Is into Z plus Vr. So now guys, if I want to find the values of what values, your A and B, compare this equation with this equation. Okay, so now you see that here this is AVR, here VR. So you compare here, your value of A will be 1. You compare here, your value of A will be 1. In the same way, here it's written BIR, okay, and here it's written IS into Z. But here we have also already seen that IS equals to IR. We have already seen IS equals to IR, so I can write my B will be equals to Z. So finally guys, you see that I got the value of A1, the B, Z, C 0 and D 1. The expression become, I will write VS, IS, A, B, C, D, VR, IR. VS, IS same, the value of A 1, value of B Z, value of C 0 and value of D 1. So this is the parameters of short transmission line in form of ABCD parameters. Okay, so this is the way how we calculate the parameters of short transmission line. Another thing is that guys, as an electrical engineer, it's very important to draw the phasors. Okay, because I don't have the you can say the physical class. Otherwise, I will draw each and every step for you so that you will understand better. But now we don't have the choice. Now for short transmission line, okay, as I've already discussed with you that this load may be resistive, may be inductive, may be capacitive. Okay, according to that, your phasor will change. You know that for resistive, your voltage and current should be in phase. For your inductive, current should lag the voltage by an angle of 90 degree, but it's not 90 degree, it's less than 90. For capacitive, your current should lead the voltage. Okay, so that's one concern. So now we have to draw the phasor of short transmission line. Okay, we have two equations. Whenever we draw the phasor, we satisfy our equation. First equation we have seen here. This is this equation, Is equals to IR, and second is this equation. Okay, so I have written these equation here. Is equals to IR and Vs equals to Is into R plus Is into XL plus VR. Now how we draw the phasor? Just take a straight line from here. Draw the VR. You can start as an engineer. What we do is that we always pick the receiving end and then we represent each and every element or the component on the phasor. Okay, so in receiving end there is a voltage VR and there is the current IR which is flowing across this load. Okay, so what I have done is that I have taken the VR as reference. Okay, if VR is the reference and your load here is inductive. If load here is inductive, guys, it means this current should lag this voltage by a certain angle. Okay, so that is why this is the VR. So this is your IR. Means for this voltage, your current is lagging. Is equals to IR. Don't see this thing. I will tell you this thing also again. IR is lagging the voltage by an angle of phi r, receiving end phase angle. I can say that. Now you see that guys, this is your IR and this is your voltage. Now this IR, because Is is equals to IR, when it will flow across here, the resistive and the reactive component, there's a drop IR, there's a drop IXL, or I can say Is into R or I into XL. So that is why guys, there is a drop of Is into R. Okay, so this is the voltage. What we do is that this is the current. So in the same direction, we'll take this point here. In this direction, there is Is into R drop. Now there's one more drop, that is Is into XL, leakage reactant. So that is drawn 90 degree, or I can say the perpendicular to this drop. And what will be the resultant, guys? The resultant will be your R plus XL will be Z impedance. So your resultant will be, guys, your impedance. And your everything has started in a very simple language with your source voltage, or I can say your voltage at your sending end, okay, Vs. So finally your resultant will be your Vs, okay. And as we have seen that sending end and receiving end current are same, so I can write that Is equals to IR, and then for this sending voltage my current Is will lag by an angle of phi s. So I feel that it's sufficient for today, otherwise it will be too much, you can say, then it will be difficult for you to understand all those things. But I feel that I want to finish it now. Okay, and in next time we will see all other numerical things, T line, pi line, and then we'll try to some of the numerical problems also. Okay, so I will stop now, and if you have any questions, you can ask me, otherwise no issue. Yeah. Guys,
Thank
are you sleeping now? Students, are you sleeping?
No, we're not sleeping, sir.
Okay.
Sir, I just wanted to ask.
Yeah.
I wanted to ask if when you said you're posting the notes that we did on nuclear power station and others, are you gonna post also the one that you started on transmission, the handwritten one?
No. You see that student, you have to hear all those things very carefully. I've told it so many times that today or maybe tomorrow I will post for thermal, hydro, as well as nuclear nodes. Those are the slides. But when we will complete these transmission line, then only I will post these notes. Otherwise, you can refer it from the book. Okay. So once we complete the unit, then I will post the notes. It's always in that way I follow.
Oh, can you please then post the name of the books on the
MS Team? Yeah.
Yes,
Okay,
please,
definitely.
so that we can at least look for the books.
No problem. You see that I also have the soft copy. I can give you the soft copy, but DUT has now made certain rules that a lecturer is not allowed to give the soft copies to the student. You have to get it access either from some publisher or from the library.
So can I come and steal it from your office?
You can't steal it from my office because I'm not allowed. Earlier, I'm giving the soft copy so that the students are saving their cost. But now the university had made certain rules. I'm not allowed to give you the soft copy. I have so many books of power system. From last so many 10-15 years, I'm doing research in power system. So there's not a problem at all. But I will post the name of the book. So that is not the issue.
Okay, thank you, sir.
Yeah, students, any other concern, please let me know if you have any problem or any concern you want to discuss with me. Students, or should I stop?
Do you have any past tests or anything to have a reference to?
What? Come again?
Do you have any past tests or any other type of questions that we can work on? Maybe tutorials or something?
You see that I say that because last year I have not taken this subject because I have started taking the subject of BNG only, but just try to follow that what we will discuss in the class, then it's sufficient to solve the problems now. And I will post some notes also in the form of tutorial so that you will understand. So because first let me solve some numerical problems, okay, then you will try to see some others. Then it's good that you will be able to know the better all the concept and other things. Okay.
Okay, thank you.
Yeah, thanks. Guys, do you have any concern or should I stop recording now? No, so I'm now stopping the recording now. Okay, if you don't want to, or you can see this lecture later also if you have any doubt.
Okay, thank you, sir.
Yeah, thanks.
Okay, sir, thank you.